Hello everyone. Today let's solve the problem Sereja and intervals. Right. So let's solve the problem Sereja and intervals. So this was asked in Codeforces round 215 division 1. So you can just go through the question. It is very easy to understand. I'll just summarize the question so that it will be easier for us to solve the problem. So just give me a second here. 1 second. Yeah. So what the question states here, Sereja wants to write n nested intervals. So this is intervals based question, right? So here Sereja wants to write in non-nested intervals L, R. L, R. This is nothing but represented by Li, Ri. Sereja wants to write non-inserted intervals L, R in the range 1 to m. In the range 1 to m. Just remember this one. In the range 1 to m. Right? In the range 1 to m. Such that at least one interval starts at x. Such that at least one interval starts at x. No interval can be fully inside another one. So just keep this in mind. This is very important. No interval can be fully inside another one, right? So while discussing the approach or while writing the code, this matters a lot. No interval can be fully inside another one. We need to find the number of valid ways to construct such sequence of intervals. What is our main goal here? Our goal is to find the number of valid ways to construct each sequence of intervals. So this is the question basically, right? So there are certain criteria they have given for this. They have said two sequences are different if at least one interval differs in the position. Two sequences are different if at least one interval differs in position, and we have to return answer modulo 1e9 plus 7. 1e9 plus 7 is nothing but here 10 to the power of 9 plus 7. 10 to the power of 9 plus 7. We have to return the answer in the modulo 10 to the power of 9 plus 7. Right. So two sequences are different if at least one interval differs in the position. So they have given this one. Yeah, this is fine. So this is the question. Again, I'll just read this out loud. Just try to understand. Sirija wants to write n non-interval n non-nested intervals L, R in the range 1 to m, in the range 1 to m, such that at least one interval starts at x, such that at least one interval starts at x. No interval can be fully inside another one. No interval can be fully inside another one. We need to find the number of valid intervals, valid ways, sorry. We need to find the number of valid ways to construct such sequence of intervals. Two sequences are different if at least one interval differs in position. We have to return the answer modulo 1e9 plus 7, nothing but 10 to the power of 9 plus 7. So this is the question. I hope the question part is completely clear, man. Very easy to understand, right? So let's do one thing. So let's go with the input output here. Let's go with the input output here. Means let's carry on with the example. Here they have been given n, m, and this one is nothing but the x. Accordingly with the question, this consists of n is 1 here, m is also 1, and finally x is also 1. This is n, the second one is m, this is x. Accordingly with the question, the output that we need to get here means the number of valid ways to construct the intervals, sequence of intervals is 1 here in this case, right? So only the condition is Siraja wants to write n non-nested intervals L, in the range 1 to m, such that at least one interval start with x. At least one interval start with x. That's what they have given. So here in this case, this is output is 1. Output is 1. No other intervals can be formed. So here the output is 1. Second is here n we have been given 3, m we have been given 5, this one x we have been given 1, and the output is 240, and for this one the output is 6. Same thing goes for the example 3 as well. So let's discuss the approach first, followed by the complexities, and then let's write the code. One thing I want to tell you, so I'll be considering the first example as usual. So I'll be considering the first example as usual. I insist you to try out with the second or the third example, so that you understand the problem clearly. Means your intuition may be different, your way of approaching to the problem may be different, so your way of seeing things for this problem may be different. Your code might be better, your understanding may be better than mine. So I insist you to try out at least with a different example, right? Rather than considering the same example, I insist you to try out with a different example. Means I insist you to try out, you can just try out the same, the same approach that we'll be going with, or that I go with basically, but try to understand with a different example as well, right? So you'll get the different perspective, and also, as I have said, your way of writing the code or your way of understanding the problem may be better than mine. So I hope the question part and the input output part is completely clear, man. Right? So I hope the question part and input output part is completely clear. First, let's discuss the approach, then complexities, followed by the complexities, and then let's write the code. First, as usual, let's discuss the approach first. So here I have considered the same first example that they have given in the question. So here we have n equals 1, m equals 1, and also x equals 1. The output that we need to get here is 1 as well. So first thing I want to say here is we will be making use of the 3D dynamic programming. So basically we'll be going with the dynamic programming approach. So just keep this in mind. We'll be going with the DP, 3D DP. Right, so let's go with the step-by-step explanation, or let's move on with the step-by-step explanation here. So we are considering the input n equals 1, m and x is also 1 basically. So we need exactly one interval between 1 comma 1. M we have 1, so we need one interval exactly between 1 comma 1. All the possible intervals are this one. Here we have only 1 comma 1 because m we have been given 1, because n and x we have 1, also we have m equals 1, so all the intervals would be 1 comma 1 itself here in this case, 1 comma 1 itself, because it must start at x equals 1, which it does basically. Here see, x we have been given 1, it starts with x equals 1, and since there is only 1, there is no nesting possible, means m we have been given 1 here, so there is no nesting is possible. Also n we have been given 1 here, right? So m we have been given 1, it has to start with x equals 1. One interval exists at any cost, one intervals exist, they have given in the question. At any cost, one interval basically exists, right? So here it must start at x equals 1, which it does here. And also one more thing, since there is only one, there is no nesting possible. N we have been given 1, right? So since there is only one, there is no nesting possible, hence there is only one way of getting what do we call, how shall I say that? So since there is only one valid way to construct the sequence of interval, right? Right. So here the condition or the criteria is no interval can be fully inside another one. No interval can be fully inside another one. So we can create the number of valid ways to construct such sequence of intervals as only one here. Only one. And what Sereja is doing, he wants to write the n non-nested intervals. Here, the number of non-nested intervals will be 1, is 1, will be or is 1 basically, right? So you can call this one 1. So the output that we got here is 1, which is equivalent to the output that they have given for the example 1. Our approach works absolutely correct in this case, right? So before hopping into the complexities part, let's do one thing. Let's see the general idea as well. Let's see the general idea as well. As I have said, we'll be going with the dynamic programming, right? So let's see how we will be making use of the dynamic programming to write the code, right? So here, so we will be making use of the 3DDP, right? So we will be considering position used as well as open. Position used as well as open. Why we will be making use of 3DDP here? Um, because see here, we need position from 1 to m. We need position from 1 to m. In the question they have mentioned, Sereja wants to write n non-nested intervals in the range 1 to m. I have stressed this one multiple times while reading the question, right? Sereja wants to write n non-nested intervals in the range 1 to m, such that at least one interval starts at x. At least one interval exists. The output has to be 1 at any cost. One interval exists at any cost, right? One interval exists at any cost, right? So here Sereja wants to write n non-nested intervals in the range 1 to m. So this position is nothing but position starts from 1 to m, 1 to m, right? So we will be making use of used because we uh, need to know how many intervals we have opened so far. We will start from 1, we will start from 1 to m, right? So we'll be starting the position from 1 to m. Also we need to keep track, or we need to know how many intervals we have opened such far, right? How many intervals we have opened so far, sorry, not such far, so far, right? So that is the reason we'll be going with the used here. And another one, we will be making use of the open. We have to see how many of them are still open, means how many of them are not yet closed, basically intervals I'm speaking of, right? So that is the reason we'll be making use of open as well. This is the reason we'll be going with the 3ddp here. One is position, one is used, and another one is open. So don't get confused while we write the code, right? So let's discuss the transitions part here. we will we have to, or we will start a new interval. We have to start a new interval, we have to close an open interval, and we have to do nothing. These are the transitions, right? So we have to start the new interval, we or we can close an open interval, or we have to do nothing. So these three things are the transitions, right? So here we alternate between two layers, current and pre. We alternate between two layers, current and pre, for memory efficiency. For the memory efficiency, we will be alternating between two layers. One is current, this one is pre, right? So after filling the DP, the result is in the format this one. So while writing the code, if I write this one, don't get confused. So here itself, just keep this in mind. After filling the DP table, so the result is in DP M module to N N. Right, so all the n intervals open and closed. This is nothing but open and closed. N N here this part N N, whatever I have written, this is nothing but all n intervals opened and closed here. This is opened and closed, right? So this is M module 2. From 1 to M we have considered, so M module 2, right? So the final part is we will be multiplying by the will multiply by n factorial, just to count the permutations of non-nested intervals. We have to go with the this one non-nested intervals itself, right? So we have to find the number of this one the number of valid ways to construct the this one what do we call non-nested intervals. Basically the criteria is no interval can be fully inside another one they have given. We have to find the number of valid ways to construct the non-nested intervals. So we will be multiplying by n factorial to count permutations of such non-nested intervals. We will be multiplying by n factorial. So this is important, we will be multiplying by n factorial to count permutations of non-nested intervals. Nothing but in this case you have to remember we will be multiplying by n factorial. This is the main part, right? So the final thing here would be will be multiplying. This is the final thing basically, right? So this is the general idea of how we will be making use of the DP, how we will be making use of the 3D dynamic programming. And also we have seen the approach already, right? So this is how we got the output 1, which was equivalent to the output that they have given for the example 1 within the question. So our approach works absolutely correct. And also we have the general idea how we will be making use of the 3D DP. And now as we are completely familiar with the approach, let's move on with the complexities part. So what will be the time complexity here? The time complexity would be big O of m into n square. The time complexity would be big O of n into m square. Why it is big O of n into m square here? Just give me a second. Why it is big O of m into n square here? Because for each m positions, we are going with 1 to m, right? So for each m positions, we do nested loops. So we'll be making use of the nested loops over used and open, over used and open. So that is the reason the overall time complexity would be big of m into n square. We will be making use of the nested loops over used and open, right? So position, used and open are will be making use of 3D DP, right? So we will be making use of position, used and open. So here we will be doing the nested loops, or we will be making use of nested loops over used and open. So that is the reason overall time complexity will lead to big of m into n square. M because we'll be considering m positions, right? So that is the reason whole time complexity would be big O of m into n square. I hope this part is completely clear. So the space complexity would be n square into 2. So the space complexity here would be n square into 2 because only two DP layers are stored here. Only two DP layers are stored. So this one I can write it in this format. So just give me a second. What happened to this one? 1 second. So yeah, here this one only only two DP layers are stored here. This one I can write in this way. DP of 2, only two DP layers are stored, right? So this will be DP of 2, n plus 1, and finally again n plus 1. N and n we are considering, right? So this one will be n plus 1 and n plus 1. For the optimization purpose. So we will be making use of only two DP layers that are stored in this format. So whatever I have written, right? So this one basically. Uh, uh, for the optimization purpose. So overall space complexity would lead to big of n square into 2. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n square and big of n square into 2, right? So I hope the complexities part is completely clear along with the approach. As we are completely familiar with the complexities and approach, we are good to write the code. Let's start writing the code. Let's start writing the code. So let's start writing the code. So here, one more thing I want to say, they have strictly mentioned, so in a single line, print the answer modulo this one, this value. Let's consider this value everywhere. I'll just copy this one. So this will be the modulo value, right? So this is nothing but 10 to the power of 9 plus 7. They have strictly mentioned here in the output in a single line, print the answer modulo 10 to the power of 9 plus 7, right? Just keep this in mind. So first thing here would be, we'll be making use of the different utilities. So I'll just go with the utility package. So I'll just import utility package. So I'll just go with java.util.star. So this is fine. So the next step is, let's go with a class name. I'll just go with the class main here. Let's go with the class main here. So this will be static. This will be static final int mod equals uh 7. This is the value they have given. So I had copied this one, man. This is fine. Let's go with a helper function here. Just give me a second. Yeah, let's go with the helper function here to add and keep the modulo in check, right? So I'll just go with the method add here in this case. So I'll just go with add. This one will be integer a. This is fine. This one will be int index. This is also fine. This will be int b. This is also fine. So within the add method, so this will be a of idx. A of idx equals a of idx plus the index, right? So a of index basically. So let's write the simple if condition here. This one will be if a of index, if a of index is greater than or equal to mod here, if is greater than or equal to mod. So let's assign the a of index here equals a of index minus mod, f index minus mod. So basically what we are doing, we are just making use of the helper function to add and keep the modulo in check. Basically I didn't understand this one. Now I basically understand why we have made use why we have made use of this one basically, right? So here, now let's go with the main function. So I'll just give main here. This is fine. Let me remove this one entirely. So here, I'll be making use of the scanner. So here in this case, we are just going with the utility package, right? So here, we are not going with the buffered reader or the print writer for this particular program. So let's go with the scanner itself. So when we go with the scanner, we'll be going with the system out println for outputting the result. Just keep this in mind. I'm speaking of the input output part. We'll not be going with the out.println. Instead, we'll be going with the system out println, right? So here in this case, let's go with the scanner sc. This one will be new scanner. So this one will be system dot in. This is fine. So the next step would be here. We have to go with the number of intervals that we need, right? For that one, nothing but in simple terms, I'll just tell you accordingly with the approach that we discussed. We have to go with n, m, and x input part we are considering, right? N, m, and x we have to consider. N is nothing but the number of intervals that we need. So I'll just consider n here and let me assign this one to this one sc dot next. Sc in the sense this one, what do we call scanner, right? Scanner. So this one I'm speaking of, right? Sc dot next here. So next int. So this is of the type integer. So we have to consider next int here. This is fine. So the next part is m. Let me assign this one to same thing. So I would have copied the same thing, man. Just give me a second here. Yeah, let me copy the same thing and let me copy the same thing here. In here, let's change the variable names. That's it. N, m, and x. So this will be sc dot nextInt itself, scanner dot nextInt, right? So this is number of intervals that we need. N, m is nothing but max value or r in any interval. R, I'm speaking of the alphabet R here. Max value of r in any interval. And x is nothing but we know this is the required L equals X, means we have to compare L with X at least, because at least one interval exists here. That is nothing but X, right? So X is nothing but required L or required Li equals X. That also we can consider in at least one interval, because X has to be one at any cost, sorry, right? So this is fine. Let's move on with the further steps, man. So the next step would be, we cannot place a non-nested intervals if more than m positions. We cannot place a non-nested intervals if more than m positions, means here if n greater than m, if n greater than m, I'll just go with here, what do we call, system out println. So I'll just keep here println of 0. So what we are doing here, if we cannot place a non-nested intervals, we cannot place the non-nested intervals if there are more than m positions. That's what we are articulating the same thing in the form of code. So we don't have to return anything. I'll just give return here. So this is fine. So the next step would be, I'll just come out of this one entirely, come out of the if condition. Now we will be going with the DP of position used open. We will be making use of the 3D DP. We have discussed this one in the approach, means we'll be making use of the two layers. One is toggle and another one is max n used intervals, right? And another one is max n open intervals. These two, uh, so I have not written this one yet, right? So this one will be int, so this is fine. What happened to this one? Yeah, 3D DP we are considering, right? So DP equals, let me assign here new int of, this will be 2 n plus 2, and this one will be n plus 2 as well, right? So this is nothing but we are considering the two layers here, n plus 2, n plus 2 we are considering, right? This is nothing but the two layers, nothing but for the toggle. And maximum, sorry, this 2 is nothing but the two layers, sorry, I got confused. Two layers, nothing but we'll be using this one for the toggling purpose. And this one, n plus 2, n plus 2, whatever we have used, this is nothing but max n used intervals. This is for the used intervals, and this n plus 2 whatever I have written, this is this one max n open intervals. This is used interval, max n used intervals n plus 2. This n plus 2 is nothing but max n open intervals, right? So now let's go with the base case. Let's articulate the same thing in the form of code. Whatever we have discussed in the approach, right? Let's articulate the same exact thing in the form of code. So base case here would be, if 0 intervals are used and open at position 0, right? At the position 0, the output will be 1. When we have 0 intervals used and open at position 0, the answer will be 1, because at any cost 1, this one interval x they have given in the question, x will be 1, x will be starting from 1, right? So base case is 0 intervals used and open at position 0. So I can write this one in the form of code in this way: dp of 0 0 again 0, right? So this one, let me assign this one to 1 initially. So the next step is, we have to loop over positions from 1 to n, 1 to m. We have to loop over positions from 1 to m. Let's go with a for loop here. This one, int I equals 1, I less than or equal to m. So this will be I plus plus. So this is fine. Within this for loop, let's go with this one toggle. We have to toggle current and previous layers, right? So we have to toggle current and previous layers. So for this one, we have already discussed this one. M module 2 we went with. Basically, here we are considering iteration part is we are considering for the individual layer, right? So we have to go with the I module 2 instead of M module 2. And I said that we'll be going with current and pre to toggle current and previous layers. So this one I'll be going with a current 1, right? So current or 1. So this will be int current equals. So we will be going with current equals this one I modulo 2, and also we'll be going with the pre. this one I said or, I think. No, so this is XOR basically, not the or. So pre, we have to assign this one to current XOR 1, current XOR 1. So this is fine. So we are just toggling the current and previous layer. For the toggling purpose or to toggle, we are making use of the XOR. We are making use of the XOR, right? So don't get confused here. Just for the toggle purpose, we are making use of the XOR here. So I hope you know the this one truth table of the XOR one. So if you don't know, you can just Google it, right? So just go through OR, XOR, and this we will be making use of very uh, very often basically. So we will be making use of OR, XOR, and logical AND operator. So these are the things we'll be making use of it very often. So next topic, I'll be solving the problems on bit manipulation and math basically. You have to know it at any cost. So I insist you to, if you are following along with me or if you are doing problems along with me, so you can just go through logical AND or XOR. So these some things, and go through the some theoretical parts of bit manipulation as well, right? So I insist you to go through these things. So this is fine. Here what we did in the previous step. So we are just toggling current and previous layers, right? So now we have to clear the current layer again. I'll just go with another for loop. This one I'll consider j equals 0, j less than or equal to n. So let's increment the j. So this one will be arrays dot fill dp. This one will be current. So this one will be j comma 0. So this is fine. So this we are clearing the current layer. So this is fine. So the next step would be we will be going with the j k. We'll be going with the j and k. Nothing but j. This will be used. This is nothing but the used interval so far. K is nothing but how many of them are still open, and we'll be making use of the value v as well. Value v that we consider from the previous layer, right? So this we have already discussed in the approach. J, again I'm telling, j is nothing but the used interval so far. K, nothing but how many of them are still open. V, nothing but value from the previous layer. Just keep this in mind. So let's go with the two for loops here, nested loops. So here I'll just go with int j equals 0, j less than or equal to n, j plus plus. So another for loop here, this will be k int k equals 0, k less than or equal to j, and let me increment the k. So within this for loop, v, nothing but value from the previous layer. So this one will be int v equals dp of pre. This one will be j, this one will be k, and this one will be okay, and this is nothing but value from the previous layer. So if v equals 0 means value equals 0, we have to skip that one. We have to skip that one. For skipping, I'll just make use of the continue keyword here. So this is fine. So we have certain options. We have discussed around 4 options, if you remember, within the approach. Nothing but one option, transitions part, 3 options, sorry, transition part, 3 options, if you remember. Do nothing at I. So we don't have to do anything at I if allowed, if we have allowed only I is not equal to x. If we have allowed only I not equal to x, that is one thing. And second option is we have to we can open the new interval at I. This is second one. And within the second one itself, or you can consider third option as well, we can open and close at the same position. That is I comma I. We can open and close at the same position. And the third one, main one, or the fourth one, is we have to close and open interval, open a new interval, close and open, close and new interval. First thing, the third thing is do nothing. So we discussed this one in the transition: open new interval, close and open interval, and third one is do nothing, right? So along with this one, another one is we can open and close at the same position, nothing but I comma I. Let's add this one as well, right? So these things we have to articulate in the form of code. Whatever we discussed in the approach, the same thing we have to articulate in the form of code as well. How can I write this one? Let's see. So I'll just go with if here. If I not equal to x, then what we will do, I'll just go with add of this one will be dp of current, uh, current, this is fine, this one will be j, so this one will be k, this one will be v, this is fine. So the next is option 2, we have to this is for do nothing at I, this is for the condition do nothing at I, this is for the option, sorry, not condition, this is for the option do nothing at I. Next let's go with open new interval at I, open new interval at I. So I can just write it on this way, if j plus 1 less than or equal to n, so this one will be add of dp, this one will be current, this one will be j plus 1, as we have considered j plus 1, right? So comma k comma b, so this is fine. So now let's consider closing an open interval at I, only if I not equal to x, only if I not equal to x. In simple terms, we are going with the option close an open interval. So only when I is not equal to x, right? So in the if condition, if I not equal to x and also k plus 1 here is less than or equal to j accordingly with the criteria, so we will go with add of dp, so this one will be current, so this one will be j, along with it I'll just go with k plus 1, and pk plus 1 with p. So this is fine. So the next step would be the option 4. So open plus close at the same position, means open and close at the same position, that is nothing but I comma I. So let's articulate the same thing in the form of code. So I'll just go with, so j plus 1, I think if we don't write this one also we'll get the solution. We'll go there. Let's write this one anyway. So this one will be less than or equal to n, and this will be k plus 1, less than or equal to j plus 1. So this is fine. So let's go with add of dp. So this one is current j plus 1, uh, comma k plus 1 and v comma v. So this is fine. Let me come out of this one entirely. So here we close this one, no need of space here, so this is fine. So here we are left with certain things, we are left with only certain things, two things basically. We have to go with the final answer, that is the number of ways to use all the n intervals and close them all. We have to close them all, right? So the final answer is the number of ways to use all n intervals and close them all. So I'll just go with the answer variable which is of type long. So this will be, as we had discussed, this will be dp of m modulo 2 n as well as, and we have discussed this one in the approach. The same thing we are articulating in the form of code, means final answer is the number of ways to use all the n intervals and close them all. So the final step here would be we have to multiply it by n factorial. If you remember this one general idea, in the general idea we discussed the last approach, we have to multiply by n factorial to count all the permutations of placing the non-nested intervals. So we have to go with the non-nested intervals itself. They have asked in the question clearly. We have to count the number of this one. What do we call? What they have asked? I forgot what they have asked, man. We have to count the number of valid ways to this one, number of valid ways of non-nested intervals itself. So we have to multiply by n factorial to count all the permutations of placing the non-nested intervals. So when I say all the permutations, we will be going with the iteration part for loop, right? So we can write this one in this way: for this one int I equals 1, I less than or equal to n, so then I plus plus. So I can just write here answer equals answer into I, this one modulo mod, this is fine, modulo mod. So this is fine. Let me go with this one, println. So this will be system out println of answer. So this is fine. Yeah, this is it for the code. So this is it for the code. So let me do one thing. Before checking with different inputs, before checking the code with different inputs, whether the code works correctly or not. So let me copy paste the signature starter template first. Just give me a second here. So here, let me come here. Let me paste it over here. So let's concentrate on the logical part, man. Yeah, this is fine. Let me come here. So I'll copy this one. We have to get the output one. Let's check. I hope this works, man. Oh, we have the error. Welcome to the error part. So why I have given here +1? What is this +1? Line number 54. This one. If j, so this one has to be if j +1 less than or equal to n, right? So here why this one? This is fine. Let me delete this one typo. So while typing, I have made the mistake here. So this is fine. Let me hit the run button again. So now we are left with three errors. Array required but int found. Where int v equals dp of pre JNK line number 50. Let's check this one correctly, man. So int v equals dp of oh, this one pre of jk I have given. So I have not closed this one. Square bracket here. Let me run this one again. So yeah, we have only one error now. So this one along with this one, let me close this one as well. Yeah, the same thing, I think. Yeah. Now we have one more error. Error cannot find the symbol. Why I have given dot here? This has to be comma, right? So in the line number 54 again. So this one has to be j +1. Just give me a second here. This one has to be comma. So yeah, we are getting the output 1. Now let's try with the second input. Now we have to get the output 240. So let me run this one. So yeah, we are getting the output 240. The code works absolutely correct, right? Whatever the approach that we have used, 3DDP works absolutely correct. So here in this case, let me copy this one and we have to get the output 6. Let's see. I run this one. Yeah, we are getting the output 6. So let me copy this one entirely. Let me come here. Let me paste this one. So I hope this works for all the test cases, man. Let's see. I hope this works for all the test cases. Let's see. So here, yeah, this is fine. Let me hit the submit button. So let's wait for some time. I can clearly see here. Yeah, this one, the code got accepted, right? So whatever the code that we have written works absolutely correct. Whatever the code that we have written works absolutely correct for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities, right? For now, this is it. Thanks for watching, guys.